Okay, thanks, John. Over to you.
Okay. Right. Well, as Dave said, he wanted something a bit retrograde, and I think IMP77, being 1977, is retrograde enough. So what I'm going to do is just talk about this language that was used by basically Edinburgh University and one or two other places. It does not have its own logo, so I had to make a picture of the Lincoln imp inside the Lincoln Cathedral, so I thought that would be appropriate. Anyway, let's start. So I'm going to talk about the history of the language a bit, go into boring details about the language features, and then show the compiler in operation. So talk about the compiler, then some potential future plans for it, and then I thought I'd have a demonstration. So, history. Well, it's actually IMP is short for implementation language. So it was a systems language, similar to the use of C inside operating systems. Born 1960s, Edinburgh University, based on a language called Atlas Autocode, which was used on the Manchester University Atlas computer. So I don't have any examples of Atlas Autocode. I'd like to have a see of it to see how it compares. But the IMP was actually used to implement various compilers and operating systems. Compilers for you, Dave, PDP-11, then later ones, VAX 11, the ICL 2900, and Perkin-Elmer 32-bit machines. It was also used to develop EMAS, which is the Edinburgh Mass Access System, which was their operating system that they used. And also another operating system, which I've not mentioned, called Mouse. Now, how did I come into contact with it? Well, it was used by a spin-off company from Edinburgh University called Lattice Logic, and they used it to implement some ECAD software for chip design. And they were using it primarily for CMOS design, but Ferranti Electronics, where I was working at the time in 1982, they were going to adapt their chip design system to help design Ferranti ULAs. So it was just after the Spectrum had been designed. So I don't think you got any sort of Sinclair machines using this software. But as you can remember, it was used inside the BBC Micros and Sinclair Spectrums, etc. And I think who else was it that used it? Oh, I can't remember now. Anyway, at the time, I was the auto layout, sort of like a automatic layout of the chips, leader of the team, and basically the liaison with Lattice Logic. So that's sort of where I came into contact with it. And like, we were using this, by the way, on the VAX computers. So, what are the features of IMP77? Basically, it's a block-structured, block-based structure. So you've got a block of code which can be named as a routine or a function. You can have blocks within blocks, just like C, and a block contains more statements. But statements are line-based. So basically it reads a line and then deals with it and then goes on to the next one. So you have multi-line statements, multiple statements on a line, have the statements separated by a semicolon. So you could have to keep the whatever expression you wanted, semicolon, and then another statement. But you can have a statement going over more than one line, but you have to have the continuation marker, which is the %C shown. And %C, or C underlined, which is how it was normally displayed, is a keyword. If you want to have comments inside it, they start with an apostrophe, and the text after the apostrophe is ignored until the line end. You can have single line comments, starting with the keyword comment, which will be demonstrated as %COMMENT, and then the text after that is ignored until line end. You can also have comments between curly brackets, and that can those can occur anywhere between the identifiers, keywords, etc. So that happens. However, new lines not allowed inside that sort of comment. All the keywords inside IMP start with a %. So you've got to think of the % sign as actually starting to underline the keyword. Keywords, case insensitive, but are converted to ASCII uppercase. None of the Unicode stuff at the time. And I think they might have used EBCDIC at the time as well. So an example of a keyword like begin could be shown as BEGIN, and then you can have the uppercase and lowercase, but it will still get translated back to begin, all in uppercase. Other keywords, cycle, repeat, for, while, routine, and record. And I'll go over these later on. You can concatenate the keywords, and in some cases abbreviate. So you've got integer, function, or you can join the two together to become integer function, or shorten it to integer fn, where the integer will be prefixed by a %, and the function by a %. Here, it's just all one section, % integer function, or % integer fn. Identifiers. They don't start with a %. They can have alphanumeric letters, digits, and you can have a space in between, or more than one space. So you could, for example, here, you've got Fred, F space R space E space D are all the same identifier, Fred. As you might guess, this can be a problem if you're looking for the keyword, the identifier inside your source code, if you've put an extra space character in and put it in somewhere else. So I don't know whether that's a good feature, but it's one that they have. Sorry, next one. You've got various operators available. The various sort of things for assignment are equals means it's assignment, it's not a comparison in this case. You've got comparison, you've got assignment of pointers effectively are done by the double equal sign. And then you've also got the forced assignment, which is shown by that. You can do add, subtract, the single plus for normal integers, etc., double plus for the incrementing addresses. Then you've got the multiply, divide, etc., and the various shift operators. You can do comparison by comparing again, but you can use the equal signs in this case, less than, greater than, not equal, and so on. You've also got logical operators saying and, or not, and these are down as IMP keywords, right? But there's a thing about logical operators, which I'll go on to a bit later. So these are all the things you can do. What data types does IMP have? Well, it's got real numbers, but they're stored as 32-bit or 64-bit accuracy. Integers, 8-bit, 16-bit, 32-bit. Obviously, so you could say the 32-bit one is the long integer, short integer is 16-bit, byte is just obviously the 8-bit ones. If you want a string, you're showing by saying the keyword string, and then you specify the maximum length that the string can have. Yeah. If you don't indicate how that bracket 3 close bracket, it assumes 255 characters. So basically, you may get the hint that there's a byte in front of the string stored, which indicates the length. If you try to store more characters into a string, say, for example, a string of 2 size, it'll give you a compiler error. Okay. Pointers, they're indicated by the name keyword, so that you can say integer name Fred. So Fred would then be a pointer effectively to an integer. You do assignments for pointers by using the double equals sign. So here, example, you've got an integer, Baggins, which has the value 4. Integer name Bilbo. So Bilbo is a name, so it's a pointer, but hasn't been assigned any, where does it point to? And in this case, it's the assignment of Bilbo is going to point to where Baggins is. So therefore, if I sort of wanted to print out the value of Bilbo, it would then show out the value 4. Now, this is the bugbear that people might think. There isn't a logical or Boolean type inside IMP77. You can do logical expressions, is A greater than B or whatever, and you can do that in your tests. And they're used in tests like the if statement, until statement, while statement, etc. But no Boolean. But we can have special functions called predicates, which return either true or false, so that you can define a function which will return true or false inside a test for like an if statement, etc. Oh, sorry, we'll go on to those later. What else can you have? Compound statement data types. So you can have an array of integers. Notice we've used a space inside here to say amounts owing, and then a range from 1 to the number of customers that you want. So of course, all array elements, same type, blah, blah, blah. The number of dimensions allowed depends on the compiler. Unfortunately, only one-dimensional arrays can be initialized. So you could set up an array, a string array, for example, with all the names, but you can't have it as a 2-dimensional. It must be 1-dimensional. Records, usual format, usual sort of usage. You're bundling data types together. So for example, here's a record format defined called IBJ line, which has the first field is a byte called the type, and then the second field, the data, is a string with maximum length. So a variable of this record format has these 2 elements. And here's an example of defining and declaring a record thread of this type IBJ line. Yeah. Quick sort of a glimpse over the grammar. Basically, a block is begin followed by statements and then end. And a program is a block. So a statement is either a declaration, an assignment, a conditional execution, a jump, or a calculated go-to. It does not have a case statement in it. It is got the switch type statement, which is similar to that used inside C. So that if you do the calculated go-to, you also have to make sure that you jump to somewhere, if each sort of entry would follow normally onto the next switch element. Of course, you've got loops, and then you can call routines and functions. So I think we've possibly got the idea about how to declare variables in IMP. So here I'm declaring Fred, Joe, and Bill, which are by default when you say integer, it normally assumes it's a 32-bit integer. You have to, if you want to just specify it as a byte, you'd have to put, say, either byte or byte integer in front of it. Declaring functions, routines. Well, this is a function, Fred, which has two parameters, both integers, and returns an integer value. So therefore, you could take these two parameters and do some work on it. And then here is the way how you return the value, the integer value that the function is going to specify by saying result equals, and in this case, take parameter 1 and 4 times parameter 2, and then terminate the function. You can have external routines stroke functions called up. So I want to be able to, I want to call inside my program, I'll call the routine Fred, and it'll return a real value. It'll take a real number as an angle, but externally, it might be known as a cosine function. So Fred is effectively the cosine, it's meant to be the cosine function, but I don't actually define it. I don't actually sort of implement it inside the code. I specify that it's going to be there. So Fred's a name inside IMP, but the linker or the external code refers to it as underscore cosine. So cosine could be written in C or even assembler. If you want to do multiple statements, if statement can be done by if Fred is greater than Joe, then we're going to start and we can do some statements there. Once that condition, so inside here, Fred is greater than Joe, we'll do these statements. Otherwise, we say finish, else start, have some statements, and then end that. So that's if Fred is greater than Joe, and that's if Fred is not greater than Joe. A single statement has got two forms which can be sort of tricky to spot. You can say if a number is greater than 10, then set the error code to be 5. But you could also say set the error code to be 5 if the number is greater than 10. So you can invert the condition. You've also got the what they call the not statement or unless statement, which will say error code is you do this normally unless the number is less than or equal to 10. So this is the inverse of the number greater than 10, number less than or equal to 10. Yeah. Calculated go-tos. You can have a statement labeled. So you've got error, colon, which is the label, and then you can do something there in a statement. Notice the semicolon to separate the print string, which is a system routine to just print the string out on the current stream, and then 2 new lines. The go-to is specified by using the dash greater than sign. So it's like a pointing to it. But you could say go to error, or you could say if det is greater than 24, then go to error. And again, the usual thing of you can use the unless. Now, the calculated go to is the same as a switch, as I mentioned before. So you declare it as a switch, Fred 3. So that means it's got 3 possibilities to be stored. And so you'd say, right, you declare the switch, and then you'd say jump to Fred, depending on what that value. But n has to be in the range 1 to 3. And then you'd have the label statement, Fred 1, and then you'd say do whatever you want to do, bill, increment bill by 4. But you only get here if n equals 1. Okay. Loops. Loops are the cycle repeat construct. So the cycle starts effectively the repeat loop, and repeat jumps back to where the last cycle bit. So if you want to do a for loop, you'd say for I equals 1, start, step, and then the last check, cycle repeat. So for example, for you can do this as, again, the same sort of trick of putting the for command after the individual single statement. So you're going to go through for K 1 to 50, and all you're doing is adding to J the XK. Okay, so as I say, this sums up the values. For the while statement, again, you've got the while, cycle, repeat. And then you've got a repeat until loop. So it's cycle, code, repeat until, and then the test, and that will give you the exit. You can skip out of loops by using the exit statement. So you can say exit if Freddy is greater than 34, and it goes straight to the statement after the repeat. If you've got like a for loop or an iteration, then you can use the keyword continue to say, okay, skip the following sequence statements after me and just get to the repeat point, which gets you back to the cycle. So it doesn't get you out of the loop. It just ignores the statements after it. Routines, yeah, usual thing. They have parameters but don't return the result. Functions have parameters and must return the result. So if you have it, you can either return a real, an integer, or a string value. You assign it using the equal sign, and then if you want to say Fred equals cosine with the angle, then the cosine routine will be called up with the parameter angle and return the value in Fred. These are all just bog standard computer languages. If you have a function which you want to return a name or a pointer, then that must be assigned using the double equals. If you've got a function which is going to return an integer or something like that, you return the result by saying result equals 42. Right. Having gone a very quick overview of the language, I'll go and talk about how the compiler's architected. The compiler has 3 phases. Phase 1, it reads the IMP source and generates an intermediate code form with also a listing file. Phase 2 reads that intermediate code that's just been generated and generates the machine code and some various symbolic data, the IBJ file. And phase 3 reads that symbol data to generate the object code. So that's object code. Now this object code is actually COF, Common Object File Format for Windows. So, as I said, mentioned earlier, there is a version of the compiler which generates ELF code, which I've got to go through and rejig. Each phase, so phase 1 is one program, phase 2 another program, phase 3 a third program. Program compilation, just run the 3 where they're connected by the various interfaces. The interfaces being the ICD file, the intermediate code file, and the IBJ file. A language can and will use library code. So some of the library code is written in IMP77, and the core runtime library has been written in C, which is usable on Windows and Linux. Project object files, the program object files, must be linked by the appropriate linker. So the Windows linker from Visual Studio or the Linux linker from the GCC collection. Slight problem. Phase 2, only an Intel 386 code generator is available at the moment, right? So you have to have a 386 processor to run this or get this generated. I thought I'd have to have a little diagram in, so a quick scribble to indicate. Here's the pass1. It takes in the IMP source. This standard perm.imp is basically a definition of all the potential routines you could use from the library. So we can have a look at that file later. These go in and it generates out this ICode file and the listing indicating whether or not you made any mistakes or otherwise inside the actual source code. So if you wanted to run it directly, you'd have to go run the program I32P1, which is the pass1 program, declare the which program you want, the by the %1 imp file, reference a standard perm file, then the outputs are given by the ICD, and notice the ICD:B means it's going to be a binary file. You have to specify that to let the compiler know it's going to be generating binary file. The slash in this case separates the input files from the output files. So pass1 written in IMP, common to, now this is actually common to both the Windows and the Linux compiler versions. So you'd use the same pass1 source code for those two. As I mentioned, it runs the reads the IMP77 source. It uses a table-driven parser, and there is a parser generator system provided inside the IMP32 zip file called TakeOn, and so that's a separate program. This program takes the IMP grammar, reads it, and generates the tables, which are then used by the pass1 compiler. So it's a bit like Yak and Lex, sort of. Pass1 generates this intermediate code, which is common to all the machine operating system versions of the IMP77 compilers. The intermediate code can be extended. Well, I'll show some examples of this later on, of what the intermediate code looks like. But you could use it to have the front end to read Pascal if you wanted, but you'd have to modify the grammar that's fed into TakeOn, etc. Pass2, generating the code. Well, the ICD file, the intermediate code file that you generated from pass1 and the IMP source get fed into the pass2, the code generator, which generates the code listing, so like the pseudo assemble listing, and this IBJ file. So you've got, if you want to run this directly on the command line, this is how you do it. So pass2, this is all again written in IMP. Its source is common for Windows and Linux. There are other versions of this pass2 for other obsolete machines like the PDP-11. So Dave, if you want to sort of have a bit of fun and games creating a PDP-11 version, the way is open. Unfortunately, there aren't any compiler executables available. There is a compiler version which runs under VAX VMS, which I was happily playing with on my SimH version of a VAX machine. Unfortunately, HP have now stopped giving out the free licenses, so it's going to be very awkward to get it up and running. There is another version of the pass2 compiler, and 1, 2, and 3, running for RISC for the ARM, right? If I get a RISC environment set up for my Raspberry Pi, I might have to have a try on it. But Pass2 depends on the format of the intermediate code generated by Pass1. Pass3, this IBJ file in, reads that and outputs a COF object file. Again, this is on Windows. For Linux, that would be the ELF format. So it would generate ELF format object files. So yeah, the Windows version, it's 32-bit PE COF object. Linux, 32-bit ELF. These are actually implemented in C. So when you look inside for the Pass3 source, you will find some C code. However, I have been busily working to create a version of the Pass3, which I've successfully done and implemented that in Free Pascal. So if you wanted to mess around with that, you've also got the source code for that inside the zip file. I assume that if you want to play with that, you'll have to get Free Pascal loaded onto your machine, and then you can compile them. Okay. Oh, these are the various utilities I've written. ICD to assembler. So basically it takes the binary format, because ICD is in binary format, and generates a textual version. So of course you can then sort of say, what's the compiler Pass1 generated? Look at it and see, are there any mistakes that are occurring? I can also reverse that from the text version and generate the ICD. So these two are, again, the part of the utilities that I've done. You've also got the IBJ to assembler text. So it reads the pseudo binary IBJ file, generates a textual version, and reverse it from text version to IBJ. So that you can use to basically sort of, if there's any mistake in the binary IBJ that you find, you can run this, look at the text and see, this is where the problem is. Now, also for the IBJ tools, there's the IBJ to COF. So basically, this is the thing I mentioned earlier, which reads the IBJ file and generates a COF object file. So it's equivalent to Pass3. So if you wanted, you could use this file instead of the C version, etc. By the way, the my version of the IBJ to COF is a bit more careful and sending out of comments when it finds errors than the Pass3. Or IBJ to compact, basically the IBJ file contains some stuff which doesn't need to be there, like some unused external symbol references. So it will remove those, and also duplicates of references you've got to lines which are not there. Also COF to dump, which reads the PE COF object file and generates a debug dump file. It's similar to dump bin that you get from Windows. So as I say, all of these are written in Free Pascal, which is another retrograde language if you want it. Right, what are my cunning plans for the future? I want to be able to, Pass2 at the moment does not allow you to embed machine code inside the IMP source. Having said that, the Pass1 will allow you, it will parse the potential machine code and generate the ICD file with this embedded information, but Pass2 just basically barfs at it. It does not like it. So I have been working on inside my future version IMP2020, which can read and can do some things with this with these machine code specified inside a file. And I'll show you an example of how the machine code will be specified inside an IMP file later. Other task. The runtime library, inside the library file, there's a file called runtime.c. And I want to get that converted from C to IMP77. So that I've got basically the complete compiler, with its runtime should then be in IMP, so it can be sort of compile and check itself. I want to also reconvert the pass3 code generator into IMP77 as well. And I want to do this so I remove all instruction selection, because the pass3 has some instruction selection embedded inside it, and put it only in at pass2. One of the instructions selection inside pass3 is jump optimization, and I don't think it should be there in pass3. It should be in pass2. Another sub-project generates the pass3 to generate ELF format, again for the IMP30, for the 386 machine. So all of these should then be up and running on Windows / Linux. Next, basically should rewrite pass2 to generate ARM instructions, and then of course modify the pass3 ELF for ARM. And if I've got time left, convert it so that I can generate 64-bit code. So that's the future, and that's what this future is. I'm going to call it IMP 2020. So it's got 2020 vision inside it. Right, I could do them demonstration now, but if you want to have any further looking up of various further information about IMP, I suggest you basically the real place to go to is this these locations. Yeah. There's also someone who made a complaint about IMP, so we'll see whether or not you agree with him or not. But that's it for the moment, and I'll now try to start. Right, I'll try and show the code. It's been very quiet, so I presume that everyone's following this avidly. Any comments so far?
I guess I'm... Go on, Tom. Sorry.
Sorry, I was going to say I have a couple of questions, but I'll save them for the end.
Okay. Right. First thing to do is to, for the demonstration, I need to have that linker available. So what I'm doing is I've loaded Windows Studio, the community version 2019. So as you can see there. So now I've got access to the Windows linker, and let's go to the IMP32 folder. So I mentioned before about the standard perm, which is the list of basic routines you can have. So I'll just show you a quick look at that. So you've got these various things. So you've got the primitive functions, basically are macros written inside the pass2 program. The runtime library has these routines down to from here to here. Some are written in, these are all written in IMP. And again, these are standalone modules. So you can talk about spaces, space, which is basically just creating when you're outputting something, it just puts the space character out. New line, a new line character. So you can read in a value and it returns a, reads data in and stored it in where the pointer type is, and so on. So you could go through, you can actually see all of this IMP source code inside the source/lib folder. Okay. Now, oh yeah. Other things to note: the IMP32 bat file is just a command script to run the compiler, all pass 1, 2, and 3 together. The multi-link program is if you want to create multiple modules, multiple object files, and link them all together, all written in IMP or something else. So this will link multiple object files together. All it does is you must have the first program, must be your main program in IMP77, and then the others can be whatever you want, just about. So let's go down to, COF is, you can see these various source files. So if you want to read those, quick note, there is a mega quick tweak to the pass3 to be a bit more helpful when it finds something wrong inside the IBJ file, which you can use, but we'll show that later. Compilers, for example, here, this is the grammar defining IMP, and I'll go through and show you how you can actually tweak an example of this later. The various compilers, parsers, pass 1 and 2, and the parser generator system. There is some documentation which I found. This may be more useful in that it's a definition, and effectively I've gone through inside the slides this booklet quickly. So you can see how he's talking about how the programs are laid out, how you can have constants, expressions, initialization, things like that. They're all inside this. Alas, EMAS IMP is no more, so I don't know that the comparison is going to do us any good, but you can there read it for a bit of history. So this document is inside the documents folder. There's also, obviously, the slides I've got here, which I used, and there's this other document as well, which tries to describe the intermediate code. Peter Salkels-Robertson was the implementer of a number of IMP77 compilers. And he was the one I was speaking to when I was working at Ferranti Electronics about IMP and how we were having to modify part of their design system to work with Ferranti ULAs. So that's the place. Oh, by the way, lattice logic no longer exists, so it's a shame, but that's it. And then this is talking about the actual individual ICode verbs and parameters, how you can use that. And I'll try and show you some of that later. Next. Right. Oh, yes. If you want to build the compiler, run the build script. But this will compile the compiler. So it's going to do the COF file generator, the compiler, and the library, and create them, but down in the appropriate folders. If you want to then release the new version of the source of the libraries and executables, run release, and then it will put them into, replace these values, these files appropriately, and even standard perm as well, because that's critical. So, all right, let's have a look at some examples. I even put some examples here. So let's go through. First example, it's a bit too big. Can you see this file now? So what we're going to do is we're going to take this information and put it into a file, and guess what we'll call it? We'll call it Hello World. So let's go into the sandpit, create the file. Well, actually, because I'm lazy, I'm only going to call it Hello. Now, one thing, the pass1 does not like a file, source file, to end like that. There must be a blank line after the last command inside the IMP source. Okay, so what we've got here is we've got the basic block, begin, end, and in between we've got two instructions, two sort of IMP statements. Print string will print the phrase hello world, and then new line puts a new line after it. Now, you could put it, print string could be now this way, and it will compile. For those that are doubting Thomases, we'll try it. Yeah. So let's go back. Now I need to go down to the source folder. This keyboard is driving me berserk. It's got a special key. It mixes the back the slash and the Z together. Right, so we're in here. So I want to compile this. Now, I could just normally just say IMP32 and then hello. I know what I've not done. Deliberate mistake is what I'll say. Let's go back to one, two, three. What you must also do is not only must you get the shell for the 86 flavor from the Windows community, but you must also use setenv as well. So this will basically sort of note where these executables are, and also the IMP32. So we can now go down. Right, compiled, let's run it. Oh, hello world, magical. Other thing we could do is, oh, and you can see now here, we've got the executable obviously and the source code. Let's do a bit more, being more adventurous. So we should have that. Now, what I'm going to do is I'm going to compile this again, but I'm going to have it demonstrate that you can actually remember some of the intermediate stages like the ICD file and the IBJ file. And I always remember these options by CSI. You can see these options described inside the IMP32 BAT file as well, right? So if you go back here, now you can see these various programs. Now, what we can do is we can have a quick look at the, which one? Yes, the IBJ file. Now, the IBJ file is this pseudo binary file where there's a counter. It's the first letter, the R, Ks, or whatever, indicate the type of record it is, and then there's a count record, and then the rest is data. What we can do is show how those work. Then the binary file, this ICD file, really is binary. So we'd have to use the programs that I've generated to dump these into text form. Now, I haven't sort of compiled up these, so I'll have to go back. And then there's a build tools, which should then add these, compile these up. Right, so I've got the various things set up. Right, so I want to dump out this ICD file, so I can just use the ICD to assemble. By the way, I made a mistake on the things. It should have been assemble and not assembler. So the input is a hello.icd, and we'll have the output as being so that should be the text version. Dyslexia rules KO. Right, so you can now see this file assemble, which purports to be a textual version of this ICD file. And so you can see there's one of the first thing would be saying is there's a language, and I'm defining rem as a keyword as being a primitive integer function. And you can compare what it says here about the rem with what it says in the standard perm.imp file. So basically, this is just a repeat of the standard perm information all the way repeated inside the file till we get to just about here, where we get to line 1. And basically, so the ICode is like a stack-based type operation. So I'm going to push print string onto a variable stack. Then, well, that push is actually pushing the function reference. Push S is pushing a string, assigning a parameter. So hello cruel world is being assigned to print string, and then we're going to call it. So you could implement this as a pure direct interpreter, or it can be used to say, right, okay, I'm going to get the print string, I'm going to get this, and if there's going to be anything other I need to do, I can do some more optimizations. And then this second in line 2, we're going to push the new line and do a call, and that's it. So you can see there how the the IMP has been converted to ICD. Next step to show is the IBJ. All right. So that will take that IBJ, which pseudo binary, and convert it to something which hopefully will be readable. Right. So you can see here. Oh yeah, there's a mistake. The pass2 always doesn't actually. This version of the pass2 compiler always thinks that the source code is test.imp. I've modified that, but not inside this version of the compiler. So that's the sort of problem. And now this is saying I want the external symbol called __ imp ix for integer exponents, floating point exponents, string copy, etc., etc. Then the commands, the imp implementations, the imp languages of the prompt, read symbol and stuff. These are all, again, mentioned inside the standard perm and also inside the library. So you can see all of these things here. And it basically sort of just generated this object code. So the object code will be, you could look and compare what it says here with what it says inside the .cod file, which is, where is it? Here. So the code file, this is representing the, oh, there's our source input. So you can see that the spaces were there. And then what did it do? It then sort of goes through and explains what did I put. So you've got hello cruel world there, and then it's going to call up this information, etc. So you can see that there and there. And in a sense, there's other examples. So one routine that isn't inside the library is what they call I2S, integer to string. And I could quickly go through and add this information into the library so that we can see how we can extend the IMP compiler library to have more functionality. So the first thing, if you look in, if I, all right, so inside the library file, I've got ITOS, which is this source code here, is already inside the file. And then there's also a thing, did I put heap in? No, I don't think I did. So I've got here this ITOS routine, which will basically take in 3 integers and then return the integer to ASCII text. And you can basically have it as more than, it can be more than base 2 or base 16 or base 10. You're going to go up to base 36 if you wanted using this routine, if you're so converse. Right, so how do I add this in? First of all, the makelib bat file, we'll have to edit it. You've got to see how here we've got, this is compiling up the main run, the main core routine, which is in C. And then I'm going to go through for each of these ones, convert from the IMP32 compiler, and then we'll add it in. So what I've got to do now is extend this list by putting ITOS on it. Okay, so ITOS is now added. It might be worthwhile. Let me just check. No, I didn't put the heap stuff in, so I'll have to just stick it with it. So I'm going to sort of leave this by adding in this ITOS routine. And then how do I get it to build? Well, where's the script? Where's the thing? Oops, sorry. There's my full command script. Let's go back. Just check we're in the right place. Right, we're in the source file. So all we need to do is to run build. And it's going to run through and compile the C files, the IMP files, etc., and also the compilers, and get them set up. And now I could release that. I've also put a "Are you sure?" type message. Right. So we've now got a new version, but one thing that I have to mention is I need to extend the standard perm library so I can use this int to ASCII, etc. So I've got to take this source code and add it to this standard perm. So it's there, added, save it. The reason why I did this build first is so that I want to have the new ITOS code available, but not yet required. So now I can go through and rebuild it again. So I'll do a build. And once that's built, I'll then release that. So I now have inside available to me the ability to use this ITOS routine. Having done that, I could then sort of go through and look on the, there's any routines which require it. For example, oh yes, it's more likely to be one of these two. Maybe not as a good example. Right, I think I've shown you how you can add things to the library. One last thing I want to do is to show you how you can actually sort of slightly tweak the IMP language, and then I think I'll cut and stop, and then you can have your questions. Okay. So to change the language, as I mentioned, we have to go through to the grammar. Now, I mentioned that the go-to, the jump, as it were, type command is the that dash thing. Suppose I wanted to change it to have some other words. I could just say go to, or I could also say it's in a foreign language. I think that is Portuguese for go to, except they say it like that, vamos para. But I have to put it this way inside the thing. Right, save that. And then what do? I just build it. And again, release. And then what we could do is have an example where I'm using a go-to. Let's see if I've got an example. Go-to. Let's modify the hello program. To say, have a label again. And we'll declare an integer. And initialize it. And first of all, let's say, go to again if I less than 10. And of course, we've got a loop here, so let's increment I. All right, so that's our new source code. So we should expect this to print out hello cruel world 10 times. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Okay, so it works. Now, so we know that that keyword worked. Well, let's try using the English phrase go to and see if that one works. Yeah. And then if there were any Portuguese people around, we could see if this works. Now, I could say vamos para, or I could split that keyword by having the underlining there and then underline again. And that should also work by saying, let's go and repeat it. Yeah. Right. I think I have kept you in suspension enough. So any questions?
Sorry, a couple of things. One thing I was wondering, in your each updated makelib, you had circumflexes after all the other lines apart from I2S. I was wondering what the significance of the circumflex was.
It's a DOS command, funny, which I found out only recently, so that you can say it can take that line in, and the command says, okay, go to the next one as well. If it doesn't have the circumflex, it's the last entry. So,
okay, got it.
So what you've got is you've got the command, and then the thing with the circumflex is almost like concatenating it to the line before.
Got it.
Yeah. So I just use that because it's easy enough then to add things, add extra routines to the list.
Okay. The other question I'm curious about is, given you've now actually you're rewriting bits of the code in IMP compared previously in C. I mean, how do you find writing in IMP compared to a more modern language like C? Do you actually enjoy C more, or do you actually enjoy IMP more?
All I can use is the cheeky expression saying it's interesting. I can show you my attempt so far. There is another, oh, guess what? It's called IMP2020. Right. So I think it's under Tools, Test. And where was it? Oh yeah, further down. Oh, one thing I must mention is that for this version that I've got, IMP 2020, I have partitioned out the run imp.c, split it up into a number of C fragments, so I can then easily modify it. So let's look at this RTL core. So this is an attempt at having the primary thing is the imp signal command, which it might be worthwhile going to the lib folder. Now, where before you'd have the run imp, you've got here the imp core, which is the core routine. So basically, it's got the dealing with things like the trap, which is like on event handlers. And here's the imp signal. So you're taking in 3 integers and doing some tweak. Now, the trouble with this is, oh, it's got the ampersand in, which means that it wants the address of imp signal and it wants the address of imp dummy. IMP77 has the address function, but it doesn't allow it to work on the names of routines, which is why I've gone on to try and do some jiggery pokery to allow this to be done as machine code. So I could go through and see the corresponding sections where it says first perm, I hope. Let's have a look a bit further down. Come on, where are you? Ah, here we go. Right, here's my attempt at saying I'm going to have the 386 mod instruction where I'm going to take the address, try to get the address of alpha, which corresponds to that imp first perm and then last perm, into this imp variable, first perm and last perm. I could have done it as means like a load store type approach. So load that into the EAX file in register and then move the EAX into that. And I could have done it with EAX and EBX or ECX and EDX, etc. This was my first attempt to try and see if I could get the address of the imp signal routine and store it in an imp variable, but this does not work. I'd have to modify the pass2 and possibly pass1 sections dramatically to get this to work. Using it as instructions it works. I know I've done that and I've managed to get this this routine to go so far, and then it crashes, but hey, what the hell, we can't have everything yet. So it's a work in progress. And you can also see things down here. One of the things I need to do, that this routine needs to do, is it needs to know the EBP, the imp, they call them the frame pointer. I think Intel call it the base pointer. So they want to know what that register value is and store it in a variable and then work on it. So that, again, I use that idea so I can also correspondingly give me the idea for this bit here. But all of this code is work in progress. It's not worth putting in onto GitHub yet because you just think it's crashing. It's not worth it. So that's why when I've got it to a state where I'm reasonably happy with it, I can put it onto GitHub. Any other questions?
Yeah, I had a couple. There was a couple of mentions of some C or C++ files in there, but is this like fully self-hosted? Like, can you compile IMP fully using IMP, or does it still require some external tools?
This is why I've got this IMP. This is why I've got this IMP run RTL core in IMP, because I've still got this IMP, this source code from the library, which is written in C. So even the IMP32 still requires C code for the runtime library. It does not require it for pass3 because I've got my my IBJ to COF program, but that's written in Free Pascal. But that's as I mentioned. Let me get my PowerPoint slides back up again. So, yeah, this is a task I'm working on. Yeah. So that one, the runtime library is now in IMP77. For me to have the pass3 be written in IMP77, I need to add random access files, which are available inside the Free Pascal and also in C. So I need to do that. But having said that, the other thing as well is this is a bit of C code. What you've also not seen is we've got, if I wanted to do heaps, which I didn't show you how to do, but you can see it inside the examples. Here's here it subverts two runtime lines to do the malloc and free, right, in C, which then become the IMP allocate and deallocate inside the IMP77 compilers. Yeah, so that's got to, I've got to find some way to convert these to not use the malloc and free. What else must I not, what I've got to get rid of? Well, let's just go through and find out where this other C source is. Oh. Oh yeah, run imp. This is sort of like the top level. So when you invoke an imp program, you're really invoking this. So you've got, where is it? The main, and again, this is C code, which is embedded inside the imp code. So I've got to get rid of, I want to get rid of this C code into the imp variant. Now, whether I do it by means of actually doing imp or having embedded machine code inside an imp program, don't care. It's just getting rid of the C program. Yeah.
Okay, so I guess long story, well, short answer is like not self-hosting quite yet.
Not quite yet. There are, if we looked on, where's the, where did I put it? Oh, yeah. If you went to these various locations, well, these two on the Edinburgh University locations, you'd find there is an IMP compiler for the VAX. You'd also find source code for an IMP compiler on the VAX. It would use, but by the way, the compiler, I couldn't get the VAX source code to compile on my SimH simulator, but then again, I probably gave up a bit too early. But that is written in IMP with VAX macro, so VAX machine code. No C whatsoever there. Okay. The PDP-11 version, this is for you, Dave, if you want to, your mission, should you choose to accept, also is written in IMP, but the trouble is there's no pass 1, 2, or 3 executables available. So you'd have to really sort of bootstrap yourself with that. So that's a real problem. So yes, that's why I put in all those things what I'd like to do.
Right. Sounds like you've got a bit of work ahead of you. Yeah, next question was, you mentioned some stuff about lattice logic and all that. Are they like any way related to the modern sort of lattice semiconductor who make
No.
No.
Lattice logic became part of European silicon structures, which then, I don't know whether they became part of Altera, who are now Intel. The person that was in charge of that, Peter Robertson, he did the, can I just have a quick drink? Peter Robertson was a compiler person. They had their own logic language called Model, and I've got the grammar for that. And in fact, knowing about having a grammar for Model and all this stuff actually started me on my work for a PhD, because I got interested in how does a compiler work? How do you sort of recognize things in a language? That, and also playing adventure games. Throw axe at dwarf. How the hell does a computer know that you want to throw the axe at the dwarf, etc.? So that's when I got interested onto languages and bits and pieces, and then found out, oh, you can have a special routine that does it, which I think is chip. So that's how I got interested in IMP, parsing, etc. But Peter Robertson was the person who was, as I say, their compiler expert. There was another person called Ian Young, again, who helped out. And he was also designing ERIC, which was the Edinburgh Reduced Instruction Computer. And I think I've got somewhere on my list of, in my sort of either attic or close by, a definition of ERIC, which might be worthwhile to have a go at, but I want to get IMP77 up and running. There is, as I mentioned also in the slides, a version of the IMP compiler for the ARM processor running under RISC-OS, and you've got the source code for that. And to do that, I can't remember whereabouts, look under languages, the archive languages somewhere under there, and you'll see, I think, stuff for the ARM and the latest versions. Okay, so that could be a program, you know, a piece of work if you fancied getting onto that.
Right. Last question. What sort of like influences IMP had on other languages? Because I noticed some very, well, I guess I would say Perl-like sort of syntax. Like,
please do not blaspheme.
Yeah, like, do you know if other languages kind of borrowed any syntax from IMP?
I doubt it. It was basically Edinburgh University. Some things might have been filtered in, but they sort of like, because it was came from the Atlas Autocode, and I think Atlas Autocode also partly influenced ANGLE 60, which then influenced Pascal and other languages like that. So it was sort of like, I don't know how you describe the line of inheritance, but I think IMP has been possibly regarded as a dead end. But I love it.
So you mentioned and the blog post, page anti-imp.
Yes.
What do you? I mean, do you agree with what he said? You just said you love imp, so I take it you don't agree with what he said, or do you want to feel like rebutting his comments?
You can love imp, but still say this child is naughty. So some of the comments, I think if I can, might see if we can get to that. Let's see if we can get it. Right. So, yeah, but this person, can I mute? I can't mute myself. This person has written in a number of languages, right? By the way, I do have one of the documents I showed you was this document, the IMP77 language by Peter Robertson. In fact, I don't know if the camera's working. Yeah, this is the book, which came from Lattice Logic, which we got at the time from when I was working with Ferranti. So I think that down here, keyword identifiers. It's an old language and was regarded as an old language. Yes. Old languages did not include lowercase letters. Well, that's wrong. You can have lowercase letters inside IMP, right? It's just that identifiers get transformed into uppercase ASCII characters. Yeah. You can have spaces inside the keyword. I think I mentioned that if you put spaces inside an identifier and you want to modify that identifier or find where it is, if you put too many spaces in, you might miss where one occasion where that identifier is referenced or used. So I agree with that. How are keywords distinguished? Algol has a few methods. When they did put the keywords out, they used bolding or underlining. So you would have, which is how I showed some of the keywords inside the PowerPoint. But when you actually write it, putting a % in front is easy enough, right? What else?
And while you're doing that, I mean, I guess one of the interesting takes on what do you think of this critique is, why did you love it?
Probably because it's like your first child.
Okay.
I started using Algol 60, then a bit of Fortran, and then Pascal, but also I had to use IMP for this chip design system. And when I was involved in VLSI ECAD, I could say it was one of the happiest times in my life, apart from now when I'm tweaking the compiler. So yeah, it's something you think back and think on with a warm glow through rose-tinted glasses. I won't say that sometimes it's easy, because even one of the examples I was going to show you was let's see. Was the example which testing the heap information out. So basically this program will use the allocate and deallocate mechanism to store dynamic memory, and then it's matters of, you've got to remember the pointers. Remember to put the double equals for names and etc., which I tripped up. And every time I tripped up, the compiler, the compiler compiled, when I tried to run it, the program just went crash bang wallop. So I'm not saying it's easy to use, but it's interesting to use. So that's in a sense one reason why I like it. Yeah, this is just this was just using an example of, you've got a record where you're having the record which is got link, which is a pointer to a record of this type with another record embedded inside it. This is all available on inside the IMP32 zip file as well. But to run these, you would need the ITOS routine for it to compile properly, and also the heap allocate. Actually, I didn't use allocate inside this. I said I did, but I actually wasn't. Oh no, I did. New. So there, I did use the new and dispose. So it is true heap storage. And the IMP compilers, certainly the PDP-11 IMP compilers didn't have the concept of heap storage. Everything was on the stack or constant area. Although the IMP77 compiler for the backs did get to the stage of using dynamic heap. Right. Any other questions? Dave, Tom, Otto?
My brain is too frazzled to think of one.
Yeah, it can be. It's I didn't know how long it would take to get the syntax of him across, which is why
it's quite nice. I mean, you talk about things that you did first in your life. I remember my first big programming experience was with PL1, and it's not that different. You know, it's algo-like, and it's actually sophisticated. It's got, you know, pointers. You can jump into machine code. It's quite a nice low-level system-oriented language.
Yeah.
It's you know, you can do, if you got your extra bits working, you can do pretty much anything you like in it.
Yeah. But at the moment, it's going to be a long haul. But next, I think once I've got that up, operating system.
What was this Edinburgh thing that was referred to as an operating system that was written in IMP? What was that?
EMAS. Yeah, it was, I think, ported onto the ICL 2900. So we needed 2900 because if you look at the compilers for that, there's a lot of embedded machine code. So in one sense, I shouldn't have machine code inside my source code, because then it's not truly portable. So to do sort of a proper operating system, you need to have access to the important, as it were, runtime libraries. I think I've got I can show you an example of some of the IMP routines which call up the ARM code. Let's go back to here. Here we go. Oh no, it's the library itself. Oh. No, that is, I don't know whether that's iCode flavor or, yeah, it would be. Now this is some of the code that was inside the ARM compiler. So you can see, for example, an integer function get space, which is externally known as 3L get space, and feed in, and it does these. So this is the sort of thing I wanted to be able to use and re-implement, but for the Windows environment. I'm trying to find if they've got, oh, I know where. I might have it. Here we go, prim. So this is like the various primitive routines for the ARM compiler for IMP77. So you can see we're using the embedded instructions with defining a mask, which you normally have, and then calling up routines. So move 8 into register 1, 1 into register 2, and do a STMDB, whatever that is. So you've got part of this base, the base level primitive routines are done in machine code, which means that if you wanted to move to another machine, you'd have to re-implement these in the machine code for that machine. Just as if you wanted to re-implement the PAS2 to run on ARM, you'd have to modify that code to generate the ARM instructions rather than the Intel instructions. Okay. I must admit, it's been interesting learning all about how the compiler works and sort of tweaking it a bit so that the version I've got does do some machine instructions. I can show you partly the you can see here, this is in my new version of the PAS2 compiler, and everywhere I've made a tweak, I've put in JDM, so I remember where I hacked. Now, So this is the routine machine code. So machine code effectively is one of the ICode, the ICD instructions, which has a parameter of a text which represents or describes the machine code instruction. Unfortunately, the PAS2 for the IMP32, it's not as neat. Let's show you the next bit here. Right. This is where each one of these shriek, double quotes, represents an ICode instruction. So if you do that, you're going to be doing an ORing, just like when I was showing you about the push and push S. So these are all, and it's cleanly laid out. I really sort of feel quite happy with this bit. But I could go through and show you the IMP32 version. Now, can you see here? You've got the command $, which says I'm going to define a variable, and then there'll be some bits and pieces. Now, if we looked at for define var, codes elsewhere, and reading the information is sort of like reading one of the tags, and all the other bits and pieces is embedded inside that. Whereas with this one, let's look for $. Yeah, define var takes as the parameters the data. So you're parsing it, but the parameters that you're reading are fed in to that define var routine. But the IMP32 doesn't. That's why I cleaned up the IMP32 source code to be a bit more like this, which is a bit more like Peter Robertson's style of compiler writing, which was an influence on me. So, and you'll also see, if you look on this one for machine code, yeah, if it sees the command which is generated by the PAS1, the W, which represents, oh, I'm going to define some machine code, it aborts. It just says bath, which it tells you why it's doing it. It said you've tried to implement some machine code. Yet this one, machine code, where's $? Sorry, machine code is W. I'm going to call it the routine, which deals with the machine code, and the parameter is some ASCII text terminated by the semicolon. So here I allowed the call to machine code. And then so here's the routine, and this is, it takes that code and reads it again and again. And I've tried to put in explanations of what I'm doing, so you can see how I'm working on this. I'm afraid the IMP32 one is, to be polite, implemented, but not as tight as it could be. So, but I think if those of you who do have Windows-based machines, it might be, you know, interesting for you to try at least to try some of these examples I've put. So example 0 was the one about the hello world. Example 1 is adding in an item to the extra routine to the runtime library. Example 2, if you want to try, is the heap storage. So I could add genuine, the new and dispose, new and free. But this requires you to look for that where it says abort constant name, because I'm having to have the nil identifier to represent the null empty record. So I needed to modify by putting this information into the thing. So hopefully you could see where you're going to tweak PAS2 for that. And then you've got the routines for the heap storage for new and dispose written in IMP, but calling up the C code. What I'd like is to have these routines, not reference the C runtime library. So that's, and then of course the test heap program as well. And I'm going to use a test heap program to also demonstrate the tweaking the grammar, but I've done that. I did that with the earlier with the hello world, doing the iteration. Example 3, what's going to do here? Oh yeah, if you wanted to add some trig functions, then here's a way to do it by, again, using C runtime library. And example 4 was, oh yeah, the grammar modification. So if you wanted to try these examples by yourself, hopefully you would get some more information. And again, oh, here's an example of attempting to have embedded instructions. But of course, this compiler will fail. It will not, it will abort machine code straight away with that. But if you wanted to, you could see how we could tweak that. This is the program in IMP, which corresponds to the IBJ2 compact, but written in IMP. So you've got all of these things. You can have include files, and you can have nested include files as well inside IMP. So this is again, and these are the IBJ commands. So IF, OBJ, data, constant, display, jump, and so on, with all the indicating how the parameters are. And if you want to sort of see how they're used, regex is requiring an external symbol. So therefore it's saying this program requires an external symbol which you've got to link and supply a value for, and so on. Unused 11 actually is wrong now. I've tweaked the IBJ language to use a thing called ref label. So instead of doing the call here, it actually has to put embed a machine code inside it for this to call up the appropriate routine. By using def label inside the PAS2, I could put I could embed that machine code inside PAS2 and not PAS3. But that's just work. Okay. I think I need a drink. And Any other comments? Yeah.
I'll stop the recording there.